Thank you, Stephanie. So this is indeed the last case study that will be presented. It's about resins for paints. I'll just give you a very short introduction to the case study, and then I will present the main results. I was asked to keep the presentation quite short, so I hope I give you enough information, but I think, well, we can always discuss later if you have more questions. So what is this case study about? It's about resins used as binders in paints. And it's actually only the binder, because only if you add a pigment, a solvent and some additives you have the paint. So the focus of this case study is only on the resin material, so on the binders of the paint. The resins that are studied are produced by DSM Resins. We have already heard some questions from Ad Hofland. He was my contact person. And I have studied a variety of resins. There are some conventional resins. They are mentioned here as old, and then there are the new resins. The new resins are both bio-based. They are alkyd resins. The name alkyd is a combination of the fact that it consists of an alcohol and an acid anhydride, and that is combined into the name alkyd. It's a bio-based resin. They are compared with two petrochemical resins. That is an acrylic resin and a polyurethane resin. And they're also compared to conventional bio-based resin. So we have a comparison to conventional petrochemical resins and to conventional bio-based resin. The functional unit of the study is resin for covering an outdoor area of 1 square meter during 4 years. The life cycle of the bio-based alkyds is as follows. There are 3 main components: the polyol or polyalcohol, an acid anhydride, and a vegetable oil or fatty acids. So this is the bio-based material that is, in my case study, made from soybean oil. The 3 components are mixed and heated. A diluent is added. Then we have the resin. Well, normally a paint is produced from that, but the production of the paint is not included in my case study. So we go directly to the application of the paint, in which we have volatile emissions, and then in the end, incineration of the resin together with the paint. Well, then I will. The reference products have very similar. Oh, sorry. The petrochemical resins are acrylic dispersion and the polyurethane dispersion. The system boundaries are the same, but the input materials differ. Next slide, please. So then I will present to you the impacts on human health. Just for clarification, in all the next slides as well, the 2 resins on the left side are the novel resins, these 2, and the 3 on the right side are the conventional resins, of which the middle one is the conventional bio-based, and the right 2 are the petrochemical resins. So what we see here is that the impact on human health is lower for the bio-based resins compared to the petrochemical resins, but you see that the solvent-based one of the bio-based resins is better than the reference mixture, the reference bio-based resin, but the other one it has higher impacts. The impacts of the human health are mainly dominated by impacts on climate change, and they are caused by the final step when the resins are incinerated during waste incineration. Next slide, please. This slide shows the impact on natural environment. It shows particularly high impacts for the bio-based resins, and that is due to the bio-based material that has a high impact on natural land transformation. So in this case, the bio-based resins have high impacts. Next slide, please. This is the impact on exhaustible resources, and we see that especially the petrochemical resins have a high contribution to fossil depletion. Metal depletion is also included here, but it's not visible in the results, so it's insignificant. These are the results on global GDP. What we see here is that I only present differences between the bio-based resins and the novel resins and the conventional resins. And you see that only compared to one of the petrochemical resins there is an increase in GDP. Compared to the other petrochemical resin, it's a bit confusing maybe. There are 5 different resins, and I want to give details on each of the comparisons. But if you have a look, you see that these GDPs are positive, these are negative, and in this case it's negative for one comparison and positive for the other one. However, This shows actually that the results are very minor. The differences in GDP are to the power of -4%. So for this endpoint, the impacts are less significant. That is, there are very small differences. Exactly. These impacts are for social well-being. The results of this exercise are from the economic model, and what we see then is that the numbers are very, very high. For example, the amount of hours of forced labor, hazardous child labor, the numbers are so high that the differences are hardly visible. There are differences, but because the assessment was made technology-wide, the numbers are so high that you cannot really see the differences. And that brings me to my last slide, with the sustainability assessment. As has been shown before, the sustainability assessment can be done by a weighted sum approach and by an outranking approach. And in the case of the weighted sum approach, the impacts are dominated by the impacts on prosperity and the impacts on social well-being that are from the economic model, and hence, and again, the numbers are so high that we cannot see any differences. Therefore, my recommendation would be to use the outranking approach. Please click on the... So if a weighted sum approach is applied, the results are very similar for all resins. However, if you use the outranking approach, you see more clear differences. And the results show that one of the bio-based resins, the Uridil 7600, is least preferable, and the other bio-based resin is more preferable than the petrochemical resins, but less preferable than the conventional bio-based resin. So my recommendation from this case study would be to always use the Condorcet rule, because the weighted sum approach gives you a less clearer picture. Thank you.
So thank you very much. Are there any questions of understanding first? Lex? Yeah.
Just one on the Condorcet rule. How can you get fractional wins? Because I noticed that you have like different size of bars on wins on different.
Can you go back to the?
Yeah. Impact on prosperity. It's on several and it's on different sizes. So
yeah, because I have 5 alternatives, it means that, for example, the Uridil can have 1 win compared to the 4 others, while the other one can have 4 wins compared to the others. So if you have 4 times 1, you only have a very small bar, and if you have 4 times 4, you have a very high bar.
Why paint production was not included?
Well, the main reason is because paint is produced outside the facility where the resins are produced. So you would need an extra project partner that tells you how they produce the paint. And I think it was just within the scope of this case study to focus on the resins that are produced by DSM resins, and not, paint producers such as Hister or so.
Okay. Any further question of understanding? One more.
In this case study, and then also in some of the other ones, you've shown 2 different kinds of weighting approaches: the outranking and the weighted normalized values. But if I understand correctly, the normalized values in some cases are good when they're high, and in some cases good when they're low. So you can't really combine them and compare them to each other.
You can phrase it differently. You can say for some elements of for some impacts you want an increase, and for others you want a decrease. So, for example, you want a decrease in child labor, but you want an increase in employment. So, if a decrease is preferable, we assign a negative impact. If an increase is preferable, we assign a positive impact.
Maybe that's already a good start for the discussion, and I hand over to Joe for the contents related.
Thank you, Alex.
Thank you, Alex.